Hi students, welcome to Year 10 Science and the motion and energy topic, and this is the first of the videos on defining the terms. What we're going to be doing here is just having a bit of a look at the way that we describe motion, and we've talked about this as the study of kinematics, which is descriptions of moving objects from kinetic energy. And we can describe the motion of objects using a number of different quantities. These include distance and displacement, speed and velocity, and also time and acceleration. These two I've grouped together, and these two I've grouped together. And there's particular reasons why we've done that. We're going to be introducing two terms that are used to separate the different types of descriptors of motion, and those two descriptors are scalars and vectors. Distance is a scalar quantity. It simply has magnitude, it just has a size. Displacement is a vector. It has direction as well as magnitude. Time is a scalar. Speed is also a scalar. Velocity is a vector. And acceleration is a vector. Whether you can remember all these or not at the moment isn't critical. But what we do want to do is make sure that we can describe motion in terms of how far something has traveled, how fast it's traveled, how long the journey took, and whether or not its speed changed at various points during that journey. So whether there were places where the speed increased or decreased. These are the sorts of terms we want you to be using when you're describing the motion of different objects. So the first thing that we want to have a quick look at is the difference between distance and displacement. Displacement is a vector quantity. We're interested in displacement in comparing the end position with the starting position. Hence, if you run round a circular track, you will end up exactly back at the point you started. Your displacement will be 0, but you may have run 400 meters. If an object travels 250 kilometers in total, but only ends up 1 meter north of its original starting position, its distance is 250 kilometers, but its displacement is 1 meter north. And this direction is very important when we're talking about vector quantities. The symbol for distance is d, which probably makes sense. The symbol for displacement is s, and it probably makes less sense, especially when we're going to be talking about speed. But the standard or SI units for both is the meter. Distance is known as a scalar quantity because it only has magnitude, and displacement as a vector because it has size and direction, both magnitude and direction. The direction part can be a compass direction, so north, south, east, west, or some combination of those. Or it may be up, down, right, left, and so on. Arrows are often used to identify vector quantities in terms of the direction of those quantities. Remember, scalars have magnitude only, while vectors have magnitude and direction. So when we look at describing motion from a graph, what we have to do is identify different regions within this graph. So at this point here, the object has started from a starting position. At this point here, we know that it has been traveling for a total of 6 seconds, and it is now 4 meters north of its initial starting position. At that point, for the next 2 seconds, its position does not change. So therefore, its displacement from here to here is 0. This is what we mean when we're talking about describing motion using graphs. So what you will do is look at describe each component of your graph. So separate all of the different sections that you can see and describe what's happening in each of those sections. To follow up, you can have a look at page 196 and 197 of your textbook just to make sure that you understand each of these concepts. And we'll have a little bit more of a look at each of them in class. Thanks for watching.